I'm Jeff O'Hare, and welcome back to Mechanical Engineering Magazine's Special Report. In this video, we focus on the importance of engineers being able to communicate and work effectively with non-engineers in the design and creation of different products. We'd like to thank our sponsor, ComSol, for its support.
Simulation software is growing more important in the design of products, especially in the biomedical industry, because of the following three reasons. One is the need to handle multiphysics problems. The next is to replace or augment costly or difficult experiments. And finally, the need to solve novel problems. What we mean by solving novel problems is, in biomedical engineering, for example, it's a combination of solving for physics, but also accounting for the biology. How do you model healing? Engineers are used to just modeling damage, for example, but then bodies heal. How do you model that? As a biomedical engineer or as a practitioner, you might have to bring in new equations to handle this. And do you have tools to kind of take that and couple it with the existing physics?
Well, simulation has two functions, really. One is to help the design effort set parameters up for optimizing a design and understanding what's going on. And when I deal with development engineers that are in the lab, it also enables them to investigate what's going on in places they can't go. A lot of what comes out is animations of what's going on with flow or heat or other physical phenomena, and they can use that to present to their management. It's a very clear way of showing what's going on, and it's a really valuable tool.
Simulation softwares make communications between different engineers, different specializations within engineering easier, as well as make it possible to effectively communicate between engineers and non-engineers.
Simulation makes communication with non-engineers more clear. Communication with non-engineers is essential, and the role where we come in is the initial prototyping and design. That involves having to understand the basic technology from the scientist or clinician that initially develops it, and then develop that into something that's going to bridge over to manufacturing.
Engineers might be interested in looking at physics quantities, whereas, say, a clinical practitioner might be interested in more physiologically meaningful quantities. So an engineer who builds products, say a software product for a non-engineer, ideally would want to take this and wrap it into an interface that is accessible to non-engineers. And over the last few years, ComSol has been developing tools to help engineers do just that. The top benefits of using simulation tools for engineers is, one, saving on time and money. Experiments are difficult and expensive. Hopefully you want to augment them. The other is to do design optimization. You can go through a lot of iterations, or also iterations you might not have come up with, by posing the problem as a mathematical optimization problem and ask the software to look for best case and worst case scenarios. It also increases creativity. If you did the wrong thing in a simulation which increases your temperature, you're not going to burn anything, right? You will just see a large value in a plot. But you would have learned out of that, so that it takes that fear of, like, what if I did this wrong? No, you'll just learn that you did things wrong. And that's very empowering and liberating.